Hi, today we're going to be using a microprocessor to perform subtraction. This microprocessor file was provided to us by our instructor. It is running in Logisim Evolution software. This microprocessor has two main sections. We have the processor section up here, and then we have the memory section down here. The memory has two parts. We have the read-only memory, and we have the random access memory. The processor has couple registers to store value and then has an arithmetic logic unit, an ALU, to perform the subtraction. And then once we get that, we get the result and store it into in one of these registers in random access memory. Our goal is to take two numbers, pass it through the processor, and then write the result into the random access memory. So let's get to it. As per our instruction, we have to do 8 minus 3. So I'm going to put the 8 in ROM 0. 1000 is binary for number 8. I'm going to put the number 3 in ROM 1. 11 is binary for number 3. Our first step is to get the number 3 into this store B register up here. In order to do that, we're going to have to turn on the read switch, and then we're going to have to change the address to 1, so it reads ROM 1. So now we see that the number 3 is sitting in front of the register here. Now we have to pass it to the output. We're going to enable the register and run a clock cycle, so that way the number 3 is now on the output of this register and feed it into the ALU. The next step is to get the number 8 directly into the ALU. In order to do that, we're going to change the address to 0 and now switch this A or B so it gets directly passed into the ALU instead of store B register. The ALU can do 4 functions: subtract, add, and couple multiplications. We have to make sure the selector switch has the correct selection. 0 is for subtract, so we have to make sure it's at 0, and we get the number 101, which is the number 5 in our decimal number system. We turn off this enable and we turn on this enable to pass this 5 into the output of this accumulator register. So let's do that. We run the clock cycle once. Now we have the 101 waiting into this buffer zone here. Now we're going to pass this 101 through this data bus, and we're going to turn on the accumulator out switch, but we get an error. It is because the data bus is now reading from 2 source. We have to turn off the read so it can get only input from the accumulator out, and now we have the 101 sitting in the data bus ready to be written into the memory. In order to write, we have to turn on the write switch, and according to our instruction, we have to write the number in our RAM 6. So we have to change the address to 110, which is binary for number 6, and then we have to also run the clock once. That way, that number 5 is now stored into RAM 6. And that's it. In addition to the demonstration, we have to discuss the following. Is this machine digital or analog? Why? This machine is digital because it is only doing input and output of a specific set of values. These values are discrete, not continuous. What is a bit? How many bits are in each of these microprocessor registers? A bit is a binary digit. There are 4 bits in each of these registers. What is a register? Why are registers important for computers? A register is a device capable of storing a group of bits. Register can store the input information temporarily for output while the computer is dealing with other inputs and functions. Where are the registers in this microprocessor? There are 5 registers in this microprocessor, 3 in RAM and 2 in the processor. What type of registers are these? These registers are serial in, serial out registers. Thank you for watching the video. Have a good day.